Hello, welcome to question 16 of the exam practice medley. Okay, so let's recognize what this question 16, which topics is relevant to. So I can see here, so ultimate stress as shear stress. Okay, so this is all about shear stress or shear loading, and that's give you a reference, page 20 of the revision guide. So let's quickly then, because I identified a keyword and I remember shear stress, and if you look at the formula sheet as well, is represented by the tau, and that is equal to the shear force over the shear area. Okay, so I can see that we are trying to shear a shape like a cylinder, so the area would be that. Okay, or the area of the hole, if you like. Okay, so we need to find the shear area if it's not given to us already, and the shear force is what we need to find. Okay, so therefore we know that, so we can just in a moment we can times this by this to find the shear force. Okay, so step one, what I'm going to do is I'm going to find the area first. So area is equal to pi r square, but because it's given me the diameter, so I can use the d version, which is pi d square over 4. It's the same as pi r square, but it saved me halving this. Okay, so just check that they are in SI unit. So 0.2 meters. Before I do that, let me just double check if this is the area, because I'm just noticing this is sometimes useful for me if I forget this topic, haven't done it for a while. It's given me a thickness of a sheet. Now when they give you the parameters, it tends to be use so let me have a thing. The shear area may not be so over an area inside material parallel to the applied load is parallel to the applied load. So what I think I should be working out then is not this. The shear area is the area around this. So let's just double check this. So circumference times thickness. Yes, it is. So okay, so warning, big warning. So I make a mistake. Well, I haven't quite made a mistake, but I would have got stuck. But okay, so it's not this. So let me emphasize this very well. So it's not that. I think I made the same mistake in lessons, didn't I? But I corrected it. I remember now. So if you think about it, if you're gonna punch this hole, it's the force to get this shape out of it is the attachment to the metal. Okay, so this is where the shear is going to happen. So this part will be the force in which to shear this. So this is the area. So to find the area, you just find the ring, the circumference of it, and times the thickness, and this will just give you the surface area of this ring on the outside there. Okay, so we don't use that yet. We're going to use the circumference, which is pi d. When I need the pi r square, when I need the circumference, I'll use pi d. That's the song. So circumference is pi times diameter. So that will give me 0.2 pi meters. And then the shear area is equal to the circumference multiplied by the thickness. So if you're not sure what letter to use, just use the wording. So C is 0.2 pi times the thickness, which is 0.08 0.004, and that comes to 0.2 times 4 is 8, is 1 decimal, 3 decimal place, so all together it should be 4 decimal place, says after the dot. So 1, 2, 3, 4, which is my 8 pi in meters square. Okay, so I got the shear area, so now I can do the last bit. If I use the last stage using brown color, so the shear force, if I rearrange the formula, is equal to the tau times shear area, and that is equal to, and tau is given us in megapascal, so mega is 10 to the power of 6, and then multiply by 0.0008 pi, remember that, don't forget that as well. So if I put that in the calculator, so 50 times, let's do that, times 10 to the power of 6 times 0.0008 shift pi, and that equal to 40,000 pi SD that, and that is how much force you need. So it's equal to 125663.71 Newton, round to 2 decimal place. Okay, so that's how much you need. So in the exam, I'm guessing is they've been doing this a lot. They round it to either they use standard form, so they would have done 125.66, and that is 123 times 10 to the power 3 Newton, or they might have written 125.66 kilo Newton, because 10 to the power 3 is kilo. Okay, so let's see if I have got the answer correct. So let's just remove this bit here so we can see. Okay, so they wrote 125 kilonewton. So yeah, so they've not even bothered with the decimal places. From a range of 125 to 126. So there you are. They accept a range of answer, and they also accept answer in standard form. So I'm happy with that.